Welcome to Chapter 6, the Chatelier Principle. Let us look at some example of how to answer the question involving Le Chatelier's principle. So these questions are in your lecture notes. Now let's try one by one. The question is, explain the effect, if any, on the following changes on the amount of CH4 by increasing the temperature. So the question asks for whether CH4 increase, decrease, or no changes. So let's look at the disturbance. So the disturbance given is increasing temperature. When we look at the word temperature, we are going to look at the enthalpy. Okay, so this is negative. If it's negative, it is exothermic. So when negative, heat is released. So we write down plus heat at the product side. Now, increasing the temperature means, okay, this is equilibrium, increase temperature. So to get back to equilibrium, we need to reduce heat. Okay, so how to reduce heat? Shift to the left or shift to the right. Okay, right hand side we have plus heat. So we go to the left hand side, which is the reactant that doesn't have heat. Okay, so the equilibrium position will shift to the left. Okay, when it shifts to the left, what happened to the amount of CH4? When it shifts to the left means there will be more CH4 produced. So means the amount of CH4 will increase. Okay, so this is the basic concept. Now, if I have full explanation, if it involves temperature, then we must mention endo or exothermic. So this is an exothermic reaction. So according to the Chatelier's principle, the equilibrium position will shift to the left to absorb heat because we need to reduce heat. Reduce heat is meaning that we need to absorb it. Then finally, we write down the amount of CH4 will increase. So this is for temperature. Next, we go to adding H2O, gas or water vapor. Okay, let's classify first. H2O is at the reactant side. So meaning, okay, this is H2O has increased. So to get back to equilibrium, we need to reduce H2O. So reduce H2O, okay, which side has no H2O? Left or right? It is on the right. So it will shift to the right according to Le Chatelier's principle. Okay, why do we shift to the right? Because to counteract to reduce the water vapor. Because the disturbance is increasing H2O. Okay, so what happened when equilibrium shift to the right? So when equilibrium shift to the right means that the amount of CH4 will be reduced. Okay, now next one, decreasing the concentration of hydrogen. Okay, so hydrogen is at product. Okay, so again, increasing hydrogen. So how to get back to equilibrium? Oh, sorry, decreasing is decreasing. Okay, decreasing. Decreasing, going down. Decreasing hydrogen. So in order to get back to equilibrium, we need to increase hydrogen. Okay, so where is hydrogen is on the right. So equilibrium will shift to the right. Okay, to increase the concentration of hydrogen. Okay, so if shift to the right, the amount of CH4 will reduce. Okay, because it has shift to the right, so this part is reduced. Okay, now next one. Okay, add helium gas. Okay, helium gas, must remember helium is a noble gas. Okay, at constant pressure. Okay, this one we discuss later. We go for another one. At helium gas at constant volume. If it's at constant volume, no changes. Means that the amount of CH4 remains the same. Okay, the amount of CH4 remains the same. Adding catalyst only speed up the reaction. So it is the same. There will be no changes on equilibrium position and the amount of CH4 remains the same. Now, adding noble gas at constant pressure. Okay, so what happened will be volume of the system will increase and thus pressure of the system will decrease. Okay, so in order to counteract the disturbance, that is the pressure decrease, so according to the Chatelier principle, the equilibrium position will shift to, okay, now let's see which, for pressure, we look for number of mole. Okay, 1 mole, 1 mole. So total 2 mole for reactant. Then this one 1 mole, 3 mole. So total is 4 mole for product. Okay, so which one has, when pressure decrease, meaning that, okay, our disturbance is pressure has decreased. So in order to go back to equilibrium, we need to increase the pressure. So if want to increase the pressure, we go for more mole or higher number of moles. So it will shift to the right. Okay, to increase the number of mole. Okay, thus what happened to CH4? The amount of CH4 will reduce. So remember, adding noble gas at constant pressure, volume increase, volume of the system increase, pressure of the system will decrease. So according to Chatelier principle, the position will shift to the direction which has more number of moles, that is to the right. Okay, thus, if the equilibrium position shift to the right, meaning that CH4 will be reduced. Okay, now let's look at another one. Increasing the volume of the container. Increasing of the volume of container means when volume increase, pressure decrease. Okay, so this is the disturbance. Okay, disturbance is pressure decrease. So when pressure decrease, to counteract, so we need to increase the pressure. Okay, same thing just now we have mentioned. This one is 1 mole, 1 mole total, 2 mole for reactant, 1 mole, 4 mole for product. So when the pressure decrease, when the volume increase, pressure of system decrease. So according to Chatellier's principle, the equilibrium position will shift to the right to increase the number of mole of gases, or the number of mole of gases and pressure. So the amount of CH4 will reduce because it's shift to the right. Okay, now another one. Okay, let's use another color. increasing the pressure. According to Chatellier's principle, what happened? Okay, if I increase the pressure to get back to equilibrium, I need to reduce the pressure. Okay, if I need to reduce the pressure, I need to go for less number of mole. So it will shift to the left to reduce the number of mole of gases and to reduce the pressure. So the amount of CH4 will be reduced. Okay, because it shifts to the not to reduce will because it will increase because it shifts to the right. So more CH4 will form. Okay, the last one, suggest possible ways to increase the amount of hydrogen gas. Okay, so this means that where's the hydrogen gas? It is on the right. Okay, hydrogen is gas is the product. So means total we want all the equilibrium position to shift to the right. Okay, so how can we deal with one by one? So if the factor is, if the disturbance, let's look for one by one. We start from concentration. Okay, so if I want to shift to the right, okay, what I can do is increase the concentration of CH4 or H2O. Okay, because when I increase the concentration to go back to equilibrium, I have to reduce it. So it will shift to the right. Another one is I reduce or I remove carbon monoxide or hydrogen gas. Because if I reduce it, in order to get back to equilibrium, then I need to increase, okay, the concentration of carbon monoxide or hydrogen. So it will shift to the right. Okay, another one is temperature. Okay, if temperature, let's look at negative. Negative means plus heat on the right hand side. Okay, if it's plus heat on the right hand side, okay, so how do we make the equilibrium position shift to the right? Okay, so it's by if we have heat here, we don't want to have more heat. So what we do is we want to have more heat. Okay, if we have heat here, but the problem is hydrogen is on the right hand side too. So how do we make it go to equilibrium shift to the right? Okay, so that is by reduce the temperature. Okay, let's try. If reduce temperature means reduce temperature, so in order to get back to equilibrium, we need to increase heat. So which side have plus heat is on the right. So by reducing temperature, hydrogen gas production will increase. The concentration of hydrogen gas will increase. Okay, another one. We have checked concentration, temperature. Another one is pressure. Okay, let's look at the number of mole. Here we have total 2 mole, which is less. Then here we have 4 mole altogether, which is more. Okay, so if we want the equilibrium to shift to the right to produce more mole, means that the pressure, the disturbance is we need to reduce the pressure. Okay, why? When we reduce the pressure, the disturbance is to go back to equilibrium, we need to increase pressure. So to increase pressure, we go to more number of mole. So it will shift to the right and more hydrogen will be formed. Okay, or another one is increase volume. Because when volume increase, pressure decrease. Okay, if we